Okay. All right. Let me switch to screen sharing, and I know that shows the slides. Let me see. Do you see the presenter mode or the other mode?
The other.
Yep, the good one.
Looks good.
It's good?
Yeah.
Okay, cool. So first off, thank you for letting me present today on our HDE proposal that we have been awarded. And so I just wanted to talk a little bit about that today and present it to y'all before we actually really get into the weeds, as we say, from the South, as far as with actually doing the work. So today, I just wanted to present on the proposal that is entitled Taming the Monster, Gamma Model Access Using Heliophysics Standards. And actually, there's several people on this proposal. The main people doing the work would be myself and also Eric Winter. And yeah, so I'll go ahead and get started with that. So I wanted to present this in a way that started with a high level overview of what we aim to do in this proposal, because it kind of really describes the context of, the proposal that was submitted and why we did it. So we intend to truly expand the community access to Gamma, and that's essentially just a MHD model that runs on an HPC system. I'm going to talk a little bit more about Gamma on the next slide, but for just this slide, that's the context that most of you should be able to know and still follow along. So in this work that we proposed, we have two main objectives. One is providing a standard mechanism to access high resolution model output on AWS. And so also just to provide a way to extract that data along spacecraft trajectories. And we proposed specific trajectories such as the Van Allen probes, Themis, and MMS. But of course, if we have the trajectories of other spacecrafts, we would be able to do that too. Okay, and so to describe, why this is, some of this proposal, some of the capabilities are actually already there. The first point, as far as providing a standardized mechanism for getting access to the high resolution model output, that access is actually there. However, it's done manually and only by request. And so if you can imagine, you run a MHD model on an HPC system and the data is stored also on that HPC system. And if it's not truly operationalized or have some kind of automated way of getting the data to the public, it just sits there or is, eventually archived or, various things like that. There has been requests in the past by just emailing the scientists for data. And the typical way that they have used or sent data to others that have requested this is by the Globus interface. This can essentially, it's a data transfer interface, and it's okay on speed, but it would be better if you could have access to all the data at once. And secondly, the spacecraft trajectories that I mentioned before as well, they do have the ability to retrieve model output for those spacecraft trajectories, but it's done through specific interfaces and also manually processed. So if there was a way to automate that or allow flexibility in that, that is sort of what we're intending to do. So why is this important? So Gamma is actually part of a larger system of models called MAGE. And this could actually give the launching point for many other applications. If you can think of other HPC models, there's a trend going towards moving the data to the cloud. And so for us, we're kind of spearheading this to move model, high resolution model output from Gamma to AWS cloud. But we can also, that's sort of the launch pad of doing a lot more, allowing access to model output for other models from the cloud. And that just enables the community as a whole to have access to greater, resolution data, but also all of it at once. And then secondly, why this is important is that we intend to use Happy, and I'm not entirely sure how many of you are familiar with Happy, and I'll definitely refer to John Vandergriff and Sandy and Tuez for any kind of detailed questions regarding Happy, because they are more the experts there. I'm still learning. And but Happy right now that I know of actually supports data, but it doesn't necessarily support model data. And so we're hoping to extend that, the functionality of that, to allow those trajectories to be retrieved from model output data through the Happy interface. Okay. So a little bit about Gamma. So it is the grid agnostic MHD model, and it's the basis MHD code and geospace code for MAGE, which is that big, system of models that we are a part of using Gamma. And I actually have an animation, and I'll see if we can play that. So this is actually a visualization of Gamma with a just simulating a actually, I believe it was a geomagnetic storm. Yeah. Sorry, the term escaped me there. But as you can see, the data for this can get really big, really fast. And so we hope to put a lot of that data onto AWS and allow the community to use it and for their applications, and also just to be able to access it originally. And so, of course, just to highlight, the model output is actually not currently publicly available. It's only by request. Okay. A little bit about Happy and its integration. So if you think about sort of layering or stacking of, I guess, our process, we're going to have Gamma being run on an HPC system, and then we're going to transfer the data to AWS, and then we're going to lay on top of that a Happy server. And that allows Happy to locate and retrieve data once we have connected the pieces. And so Happy actually is a RESTful interface. It's an API. And through a simple request through the Happy server, you can actually retrieve model, well, not right now, model, intending to be model output. But right now it would be time series data for spacecraft and different sources and things like that, as far as what is tied currently into Happy. A sample request that we would possibly use would be a wget to specify a specific instrument for what data source is coming from and a time range. And then Happy would go and retrieve from the server all the data for that instrument in the specified time range. For us, however, time is a tricky part for models because each run of a model could have different time sequences, overlapping sequences, depending upon which simulation you run or iteration of the model. And so we're hoping to extend Happy to have that functionality to retrieve data from AWS, from the data that we put onto AWS of Gamera, and be able to deliver that to the public. And to simulate virtual fly-throughs of spacecraft for comparisons, but also just to be able to have a way for people to obtain the data as well. Because this doesn't necessarily do virtual fly-throughs. It can actually obtain multi-dimensional fields through Happy, okay? And I know it's going to be probably a quick presentation, but that's about it regarding our proposal. And I'm definitely willing to take questions. And I just want to also say thank you for letting me present today.
Of course, thanks for the presentation. Does anyone have questions for Brent?
Saw there was
I have a lot for Brent, but I would prefer to let someone else go first. This is Rebecca speaking.
I had a quick question.
Yeah.
Yeah. You were talking about, the models can get pretty big. Do you have like a size scale, maybe on the order of like gigabytes of what we're talking about here?
So one Gamera simulation run, if I'm not mistaken, is roughly about 2 terabytes.
That's about 2 terabytes. Oh, wow. So
Yeah.
a follow-up question there is, have you found a way to optimize the streaming of that?
So it's kind of a catch-22 there, because we want the high resolution data. So it's going to be large, and we know that. As far as optimizing that, we're going to look at options there. Definitely streaming in parallel of data, because rather than in serial, that would be good. But also at the same time, once we get the data to AWS, it's basically there and everybody can have access to it. So the slow part, I guess you could say, in what the bottleneck there is actually that transfer. And so, yeah, we're going to look into that and see if we can optimize that, but also just do a more timely transfer as well, because right now it's not even publicly available. So
nice. Yeah, I'm asking because I'm having issues in my own personal project right now where I'm getting at some magnetosphere model data that's on the order of like 300 gigabytes, and something that takes 3 minutes to run locally suddenly takes on the order of an hour or more to like run over the network when it's getting the data. And
right.
Do you think that's like standard-ish? Does that sound about right for what you all are doing, or can you do better than that?
Good question. We'll see.
We'll see. For sure.
Yeah.
Can I say something here, Brent?
Yeah.
Yeah, because I mean, the idea is, Sean, once we get it in Amazon, that you don't download it anymore. We'll provide scripts that just run in Amazon too. And so you've got, whatever speeds Amazon can provide to data that it's hosting, you get that. You don't have to wait for it to download. So that's the whole motivation for moving it into that's half of the motivation. First motivation for moving it to the cloud is now you can put it in a kind of a neutral place where people can get accounts and access it. They don't have to have accounts on APL computers because we can't do that. And then also they can execute analysis stuff right there, and they don't have to wait for the downloads.
Yeah, so it's server-side operations at that point. Yeah.
Server-side analysis and display, and then you download the results, which are small.
Yeah, that'll go a long way for sure. That's good.
Yeah.
Yeah, that's
And
exactly what we're working on with at CCMC.
Yeah, I mean, there's a lot of commonalities here. So another thing that's come up since this was proposed is some other work with Gamera outputs to try and fit that in with CCMC. And so that means we will probably, Brent can jump in here if I'm saying too much or not the right thing, but we'll probably get some Komodo readers for the data. And then once we have Komodo readers, that's the layer on top of which it might make sense to have a happy interface, because the Komodo output is a little bit more regularized than the sort of raw underneath stuff. But then instead of just, so you've got regularized output that you're accessing through happy, and then also this sort of value added thing where you predefine certain spacecraft trajectories. Oh, you want model data for this spacecraft trajectory. And the goal is to almost try and make it look exactly like the data from that spacecraft. Same energies, same parameters that were measured by the spacecraft. So it'll be a kind of apples to apples comparison.
Well, some of the things that I wanted to jump in and offer with Brent and the project is that Komodo already has the fly-through that works with any satellite trajectory in CETA-Web. And you can use that to modify the trajectory before you fly through the data, or make up your own trajectory, or input your own custom trajectory, and so on, right? But there's also, once you have that reader in for the particular model data, it can be automatically plugged into anything we have built on top of it, which includes the fly-through and includes a satellite mission constellation planning tool that I've been giving presentations about. So it's really, you have this one script that I can do as part of my job at CCMC, or we can work together to do, or whatever works out. And then you plug into all of this capability that's already built in. So I think that'll be a huge accelerator for what you're planning according to your goals. And there's details we can talk about with file sizes and formats and all that kind of thing. But the 2 terabytes does not scare me, Brett.
Okay.
And honestly, I think this would be a great, particularly since you have some funding now, I think it would be a great thing to team up with CCMC, because we're looking for a use case for our AWS instance, particularly for having model data on the cloud and serving it with a layer, with a Komodo layer on top to provide quick execution times. And, I think it's a great idea to put a happy interface on top of that, or whatever interface winds up working out. So please get in touch with me.
Okay. Yeah, I definitely will get in touch with you and talk. We'll have more talks about this. Okay.
Great. I'll send you my email in the chat.
Great.
Awesome. Any more questions for Brent?
Oh, this is Alex, just a quick comment on the general speed up these things, right? This is why we want, like we all know ND cube exists, but again, world coordinate systems and X-array is a must here. I think we really do need to do that. Unfortunately, we put in a grant for that. It was not selected, but we're still hunting up opportunities to do that, because that's some low hanging fruit that can really speed up some visuals of these models that require that, right? And then in terms of other speed ups on visualization for, bringing the user to the data, bokeh. There are lots of things that can be sped up in bokeh. I've talked to the developers at Anaconda directly. So those are 2 big things that we should push for as a community. Nice presentation, Brent. Thank you.
Thank you.
I have one other quick question. Maybe this is more for John, but how are you envisioning the happy interface? Is that basically to the 1D output of the fly-through is going to be then plugged into happy, or are you envisioning a multi-dimensional upgrade to happy?
Sort of both. I mean, the one-dimensional thing, happy already knows how to do. The happy interface for the fly-through stuff you would hardly even know it was model data behind it, it would just look like a regular happy interface to data that just this instrument, in quotes, data happens to come from the model. And so the idea is to make that happy server so similar to the instrument data that you were getting from a different happy server that they literally could just be, you know, like I said, the apples to apples. You have an energy spectrum with 8 particle energy spectrum with 8 energies from the data. You have the same 8 energies and the same particle spectra from the model output. So it's just almost like two views of the same instrument. But then for the model data, yeah, that's the researchy exploratory piece of this, is can we use happy for something more than that? And so the thing that would be nice would be a regularized grid, which is why it would make sense to put happy on top of the Komodo thing. So
right, and
just
that's where we definitely want to work with you on that, because our interface is providing a way to get slices of data out as opposed to a point source out in time or things like that. So.
Right. Yeah. I mean, happy supports arbitrarily large dimensionality of things. So whether or not that's wieldly in this context, we've never tried it. So, it like I said, it's it's an exploratory piece. How far we can get on that on one of these 1-year things, we'll have to see. But definitely, yeah, we don't want to reinvent things. We'd like to leverage what has been done and see how happy fits with that. So do you guys have a regular meeting where you talk about development and issues and stuff? Because might make sense.
We have a regular weekly Komodo meetings and lots of email stuff. And we occasionally will invite people to come in and talk about specific subtopics and things like that. So we could certainly potentially in a future meeting have you come in and focus a meeting on this type of issue.
Yeah.
Yeah, this sounds like a meeting that we need to have outside of the regular weekly stuff, because it's going to be the whole meeting.
Yes, right. It will be.
Yeah, there's lots of cans, each with lots of worms. So
right.
We'll set something up.
Sounds good.
Yeah.
Cool. Anything else for Brent? If not, thanks again, Brent, for your presentation. Awesome discussion, guys.
Yeah,
we can
thank
go
you.
ahead. Yeah, we'll go ahead and move on to the second of the HTEE presentations, which John Niehoff will be giving.
Great, thanks. And this is kind of the other end of things, because this is the end of a project. I'm currently in closeout on that and dealing with the as I was griping in Matrix, the new technology report, because it's a surprise to NASA that the proposal to write software is resulting in new software. So yes, this was funded through the previous cycle, so ending last year, and this is what we're sort of settling it on as the elevator pitch, which is this is a Python-based database-driven process controller automating the production of the high-level data products when new input data arrive, and maintaining the history of every file. I actually just checked the first commit in our repository is 11 years old. It's November of 2010. This was put together to solve the problem for Van Allen probes of managing across multiple instruments. And I went into more detail the last report on that, but not going to go digging in too deep. So the real goal here is managing kind of the chain of processing. That is, if you have like a level 1 to level 2 code and level 2 to level 3, how do they interact with each other and link together without manually going in and kicking stuff? So it tracks all the dependencies, tracks the versions, tracks the history, that is what codes and what files went into which output file, and of course versioning of both of the code and of the data. The new data show up and you get all of the new products made from that. And the kind of core conceit here is that you have multiple input files to a single output file, and that's treated as potentially your spacecraft data, cal files, summary plots. They're all kind of treated as files, very Unixy. And our overall cycle, again, this is an old slide because that was back when we thought we were using IDL for some stuff. Sort of breaks into two pieces. New data files show up that get ingested into the database, and that's a process that basically involves scraping a small amount of metadata off of that file, and then it goes into the processing loop of once that ingestion has figured out what kind of file it is, it figures out every single possible output file, what other inputs it might need, builds out the command lines, runs that, and then with that new file that gets ingested back in, and the loop starts all over again. So as I said, this started on Van Allen probes. We've been using it also on Parker Solar Probe. It's been on several missions at Los Alamos. And the project was really about taking this existing piece of code and getting it out into the PyHC ecosystem. So that's potentially usable by other folks. And so this was kind of just little slivers of things to improve matters and make it more accessible. So the biggie really was moving from a closed or internal development process out to GitHub. There's the URL. It's all fully integrated. All of our work now gets done through issues and pull requests. We have templates for that. All of the supporting documentation and little files that GitHub treats specially. We've got continuous integration, again, hooked into GitHub, but using Circle CI. We're thinking of moving that to GitHub Actions probably, just because that's giving us more flexibility these days. The tests have been updated. The tests run on Mac and Windows. That's about as far as we've gotten cross-platform at this point. They're not tied into the continuous integration. Again, that move to GitHub Actions will probably be fundamental in making that happen. But as I said, everything happens there. We're kind of in the open now. One of the big projects over the course was to deal with that internal development because some of the work at Los Alamos diverged. And really the big things that we did there in order to resolve that, rather than trying to merge the history, we went and cherry-picked the functionality. So the big thing there is that the metadata backend can be Postgres now instead of just SQLite. They're pretty much at parity. They're both tested. In part of doing that, we went and did the thing that we recommended the PyHC standards of pulling binaries out of the repo. Those are actually now JSON files that get poured into either the Postgres or the SQLite as the unit tests run. And because, of course, Postgres has a little bit more machinery to it in terms of passwords and such, we'll probably be continuing to refine that. And the other big thing we did was just change some of the scripts that are used as the interface into DB processing, just to make things a little bit easier to write automation scripts around. So in particular, kind of getting the status of what is in the queue waiting to be processed. Another big one that really kind of related to that fork is complete rework of the documentation. As I said, this is a decade-old project, so the doc strings had some NumPy doc, they had some base Sphinx. There was ePyDoc still hiding in there for anybody who remembers that. So it's now fully Sphinx, NumPy doc, and auto-docked. And pretty much all of the Post-it notes we had knocking around, whether they be real or virtual, have been incorporated. Also, from that fork that's developed at Los Alamos, we realized we needed much better documentation of what are the underlying concepts. So that has been written up, the philosophy, the database schema. So you can see we've got a nice little graph is a representation of that, and a one-page getting started. So if you actually have a project and you want to have this manage your data production and updates, there's now like a one-page that's heavily linked out, but it is the single reference to get started. Got a few more examples tied in, including these inspector codes, which this is the only custom code you really have to write. It's just making that bridge between whatever your data format is and the metadata. And this turned up a couple of bits of legacy within the code. So there are several issues open on GitHub for cleaning some of this stuff up and clarifying and focusing a bit. But the built documentation's also up on served via GitHub, so you can look at it there. You can also, of course, pull the Sphinx source. In the realm of moving into the 2010s, full Python 3 support now. This was written to Python 2 originally. So right now it supports 2 and 3. Everything got tested against 3.10. That's in the continuous integration. All of our production stuff has been moved to Python 3, with the exception of Van Allen Prose, which is legacy. So we're going to start actually ripping out the Python 2 support. So that is always fun. And finally, all of this stuff has been released. We actually have a release on PyPy, including a wheel, so you can pip it in. Since we started this project, there's about 50 pull requests and about 20 issues. Some of those pull requests were addressing bugs that never made it to an issue write-up. We've got a Zenodo DOI. The Parker processing is actually on the release version now, so we're dogfooding that to, and we'll probably continue with that. That if stuff needs to be rolled into production for Parker, we're going to make sure it's released first. And it is now on the HelioPython, so this is basically tied fully into the ecosystem. It is out there. This is kind of what we propose to do, which is bring everything much further along in terms of our PyHC standards. The biggies really is just always need more testing, and the big limitation on the maturity front is really full support on the Mac and Windows side. I honestly don't expect any issues on the Mac side. On the Windows side, there's some issues having to do with how we want to approach pathing. But it is up on GitHub. Welcome to have people jump in and take a look. Particularly if you're thinking of this for a new project, I think it's ready. I would also recommend getting in touch with me, because this is one of those things we're having folks who are in the know on the loop helps a lot. And that gives us two things. One is it gives us the ability to see where documentation or anything else is unclear, and we can update that and provide support. But also if we need to bend the functionality one way or the other, we can help out with that. For the most part, ongoing development is going to be in support of what we need for Parker for the ESIS suite. But we're happy to do anything else that is in scope and will help people out. So that is what I've got. I'm gonna, sorry, I can't see the chat at this point. And so, yeah, if anybody has any questions, I can go back to a more normal presentation here so we can see each other's faces.
Any questions for John, anyone? Also nice presentation.
And I presume this will be sent around. So the main thing is honestly click on those GitHub links and take a look if you've got. I'd particularly be interested in, this has been mission scale for the most part, but if people have a kind of a smaller data-driven project where they say, this might be useful, I'd be really interested to know that, because sometimes there's stuff in between. Yeah, I've got 1 or 2 shell scripts to poke and a full mission scale thing. And I think the DB processing can really help with that. Just try to keep you from having to develop anything major. Cool beans.
Thanks, John. Oh, Russell.
I do have a
Russell has a
question,
question.
John.
I'll have Russell go first.
Yeah, sorry, yeah.
So yeah, thanks, John, for the presentation. It's interesting. I had mission experience myself, and I've run into the challenge of, having to identify files and all those different things before. So we kind of have a very limited process in PySat right now for identifying files that I've used for, just my own processing for Icon and other things. But we're hoping to get something more robust as a general process for CubeSats. And I just, it's good to see this presentation on DB processing. I plan on checking it out to see if, perhaps we can get that integrated into PySat. So we don't have to, reinvent all those features. And, help the CubeSat community out, and because they don't generally have the funds, to build this kind of infrastructure. So that's one of the goals that we're trying to, enable with PySat, is to help the CubeSat community actually get that full process. And I think this is an important part. So
yeah,
thanks.
please drop me a line. And one of the things that I want to be doing anyhow is but would particularly help with that is a lot of our functionality is kind of shoved into scripts right now, where we have 100-line scripts that do too much, and some of that needs to be moved into the actual modules so that it's a little bit more both primarily for testing, but also if there are smaller bits of functionality that you won't need access to.
Yeah. Okay. Great. Thanks.
Then John, I think you had a question.
Yeah. Yeah, sorry about that, Russell. I didn't notice the hand. I just just was jumping in there. But yeah, yeah, this is nice. So this really fits well with NASA's push to open source everything, right? Even the mission tools, so that we don't have to keep reinventing things. My question is, what do you estimate the sort of ramp up time to be, right? The challenge with all these things is people have been developing pipelines for a while at different institutions, different places. And so the lowest pain point is always just to copy, paste, use what you did last time, right? So are we getting to a point where it's less than that? Like, how many days would it take for somebody to be comfortable that, they could own or even contribute to this kind of code base?
Well, I think there's two questions there which are related.
Sure.
One is ramp up to develop and contribute. The other is ramp up to use it on a mission.
Well, but it's, I mean, people aren't probably going to want to use it until they felt like if there was an issue, they could get it resolved quickly. We've tried these before. We tried, what was the Apache one?
OODT.
Yeah, that was terrible. It had all kinds of problems. And the developer, I think we eventually abandoned it after a while. We used it for a while, but then it was just so hard. And then the next person who came up was going to have to spin up on it too. And it was like, we didn't feel enough ownership in the effort that we wanted to use it as our own mechanism.
Yeah, and honestly, I hope that folks would feel empowered and interested in being involved in the ecosystem and not just to grab off the shelf.
Right.
So I can tell you it's gotten easier, at least I hope so.
Mm-hmm.
In terms of having kind of a more basic layout of how the different pieces relate to each other, and what we mean when we say the date of a file and that kind of thing.
So it might be a place to look for support from heliophysics, from the data environment, to say, look, I need a little bit of support to help people ramp up on this, so that when the next group comes along and says, hey, I want to use this, that you have funded time to help them.
Yeah, honestly, it would be great if we could get some, either a mission that goes, yeah, I kind of want to jump in on this and get looped in there, or some more infrastructure type funding.
Yeah, the mission loop hook would be great, because they would have enough money to do the ramp up and really get going on it. So
yeah, and so we're doing this is, as I said, supporting some of the stuff at Los Alamos, and we'll probably be using it to some extent on Helioswarm.
Right.
But having a mission that I'm not involved in would be
yeah, that's the real thing, right? Because it starts to expand in dimensions that you didn't anticipate, and that's when you find out if it's really generic.
Yep, and that's the tricky thing. So honestly, we're starting a little bit of like a 1.0 roadmap, and the biggest thing on doing that roadmap, to my mind, is stabilizing the actual database structure, because we've even been shifting around in terms of, what columns do we have, what tables do we have,
okay,
as stuff presents, and so stuff presents itself. And so the plan as part of that is, of course, having a migration capability,
right,
and a versioning on that.
Yeah.
But sort of getting the baseline in place, so that we've got something that can actually be built on. So I think I
Mhm.
utterly failed to answer your question. Other
No,
than saying
no,
it's a
it
good
gives me a
idea.
good feel for it, actually. It's not, you can't really answer it with, oh, 3.7 days for a, a moderately experienced, I wasn't looking for that.
Yeah, what I can say is we've had folks at UNH who have come on and contributed to it, including your daughter. So
Oh yeah, that was some years back.
yeah, so we can set a bottom line of the 3 months she was here. By the end of that, she was so yeah, we've we've had people other than me write code on this. That's I think part of the answer. And in terms of answering the question that I wanted you to ask, in terms of just getting it going on a mission, the two pieces you need to do is maybe 10 or 20 lines of Python for extracting the basic metadata. And honestly, it would take me maybe an hour of work to genericize what we have for Parker into a more general CDF inspector. So that doesn't have to be completely custom written. It just needs to support whatever file format you're using. And then the config file is, about 10 lines of INI style config for each product, and then for each process. So your level 1 to level 2 of a particular type.
Interesting. So is there a repository somewhere with instances, people that have used it, and you could see a diff between it, and then, oh, look what they added. Oh, okay, so I need to do that, like almost like a template.
That's an interesting one, because I was thinking of doing a little bit of a carve down of the stuff from ESIS and getting it up there as an example.
Yeah.
And some of the stuff from RB. So yeah, I was hoping to have gone deeper on the examples by this point. But the amount of effort that went into the documentation proper kind of overwhelmed that.
That's highly appreciated, though, that documentation stuff. So
I mean, like I said, it kind of helps me, because it means when some of the guys at LANL are saying, oh, we need to have this functionality, I can point out and go, well, this is kind of the playing field, and
read this and tweak it if it doesn't make sense.
Yeah, exactly.
Great. No, this is important for, like I say, for the future, where NASA is expecting mission stuff even to be not just open source, but developed jointly across the enterprise.
I've got to say, it makes me feel better that you're ragging on OODT, because kind of the first question we got when we first presented this at AGU 9 years ago or something was, well, why don't you use OODT? And we went home and looked at it and went, I can't figure out what this does.
Yeah, it's
So they've definitely come a long ways in 10 years as well, of course, but all righty. Well, thanks, folks. I will drop my email in the chat as well, just so it's available, but those GitHub links are in the slides. So that's what we're trying to do, right? I want people to funnel through the GitHub and open discussions and open issues and take a look there. So thanks.
Sure. Thanks, John. I also included your email and Brent's in the notes for today, along with links to slides, and there will be a link to this recording. So have it in multiple places. I just wanted to say a +1 for thank you on having really good documentation and putting time into doing that. It's very important.
I'm not sure it's good, but it is comprehensive now, at least. Good is the next step.
It's been updated to the modern times, so that's excellent. I'm in favor of that.
What, ePyDoc isn't your friend?
I'll be honest with you, I've never used it. Yeah, too young, I guess. Yeah. Anyone else have any questions, comments for John? If not, we can go ahead and wrap up a little early. Thanks again to John and Brent for your presentations, and everyone for having a lively discussion. I will see you all again in 2 weeks, Monday, March 14th, same time, same place. Although by then the time change will have occurred, so it'll be 15 UTC, not 16. We're going to have another HDEE intro, and then have a small discussion surrounding a standard way to leverage fundamental space weather data sets. This was something that was brought up to me by Jenny Newth, She's another fellow employee here at LASP, and she had some questions for the community about it. So it should be interesting. Get excited. And that's all I have for you all. I'll see you all in 2 weeks.